So we're going to work on looking at series and parallel circuits. As I said, we're going to be using V equals IR. Strictly speaking, it should be delta V, but I will often drop that. But keep in mind, a voltage is always a difference. What is the difference between 2 points? When you have a 9-volt battery, you have 2 terminals, or a 12-volt, or any battery, you have 2 terminals. So a series circuit, as again I said, looks something like this, where you have the current into one resistor equals the current through the other resistor. There's no other path. So that's series, and this is parallel. Okay, so we're just going to get to the equations that set these up. So I'm going to put an R1 and an R2, a voltage source, and a different R1 and R2. And as I said before, we use current in equals current out, and delta V, we're going to say around the loop, any loop that we set up is equal to 0. So in the first case, we have current going out of the battery, and it goes through R1. It's the same current that's going through R2, and so forth. So this total current, the equivalent resistance, then we can say the voltage that's across R1, this voltage right here, V1, is going to be I times R1. This voltage right here, the delta V across here, V2, is going to be I times R2. And so the total voltage, using this voltage around the loop equals 0, says that our total voltage must be equal to V1 plus V2, or we say the total voltage is equal to I R1 plus I R2, which gives us V is equal to I, factoring that out, R1 plus R2. So R1 and R2 together equal an equivalent resistance. Okay, so this equivalent resistance is the sum of the two. So if this one is 10 ohms and this one is 200 ohms, then this would be 210 ohms. You could replace it with that kind of resistor. So for resistors in series, the equivalent resistance is just the sum of all the resistors that are in series. So that's pretty straightforward. And that should look something like what we saw with the capacitor. Now, in this situation, we know that the voltage across R1, this V1, is equal to V. So I'm not even going to label it as something different, but we can say we have a current, I1, and so we could say for this part, we have V equals I1 R1, and here, same voltage, right? And we have a current I2, and so we can say V is equal to I2 R2. So that's our voltage loop. In other words, if we went through the loop this way, we'd say V is equal to this V, or if we went through the loop through the outside, 2 different paths, this V is equal to this voltage. Then we can look at the current that comes out of the battery, this current total, if you like, and right at this point, it splits into I1 plus I2. So if we use our current in equals current out, I can say that the total current is equal to I1 plus I2. And one way we could look at this is we could say V is equal to I total, if you like, times R equivalent, right? The equivalent resistance. That would be V is equal to I times whatever these two could be replaced by. And so if we put that in, we could say then, or if I substitute, doesn't really matter. I'm going to substitute in here and in here. I'm going to say I total is equal to I1, which would be V over R1, plus I2, which would be V divided by R2, V divided by R2. Then I can substitute that in there, and I can get V is equal to V over R1 plus V over R2. I'm just trying to solve for R equivalent. The V can be factored out of this. So I can put a 1 here, and have a V factored out, and those can cancel. And I can say, in fact, that, I'm running out of space, R equivalent is equal to, I'm going to divide both sides by this whole expression, which is kind of a crazy expression, but it's equal to 1 divided by 1 over R1 plus 1 over R2. And so, in fact, the equivalent resistance in parallel is 1 over R1 plus 1 over R2 plus anything else to the negative 1. Okay, so again, that's similar to the kind of expression we saw with capacitance. So when we have resistors in series, we just add them. When we have resistors in parallel, we take the equivalent resistance, the equivalent to this plus this, is taking 1 over each value, adding them together, and then taking 1 over that. Okay, and we'll see some examples of how to do that later on. But this is the main idea. We're using this expression to figure out the equivalent resistance here and here.